So here we're talking about finding the slope from an equation. And generally we're going to see equations written like this: y equals mx plus b, where this m stands for the slope. So the y and x, generally those are going to stay as variables, where this m is going to be replaced by a number, which represents the slope, and this b is also going to be replaced by a number that's going to represent the y-intercept. So we'll get into really what that means in a little bit. For right now, we're just focusing on the slope of an equation. And actually, this equation has a special name. It's called the slope-intercept form of an equation because it has the slope and the y-intercept readily available in that equation there. So the slope is really just the number that's being multiplied times the x. So when we're given an equation, it really is just that coefficient there that's being multiplied by x. So our slope here, or m, is 4. Here, our slope is -2. Here, the slope is a fraction of 1/2. Here, again, it's a fraction. It's -3/4. On these two, I'm going to write a general equation that has a slope of 4 and a slope of 1/2. I can actually pretty much directly copy from up there. I'm going to make up a different one. I'm going to say 4x plus 3. I'm changing this number, but that doesn't really affect the slope. I'm still keeping the slope as 4. On this last one, I'm going to change the order of these two things. Normally, we will see the x term first, but I'm going to flip-flop these. I'm just going to make up a random y-intercept, but I want to keep my slope as 1/2, so the number that's being multiplied times my x will still remain as 1/2. The order of this changes. The constant is now in front, but the multiplication is still happening in between this 1/2 and the x, which means my slope is still 1/2 there. There's also two special cases of these that we need to talk about. So let's say I wanted to create an equation with a slope of 0. Let's really just use that exact same thing, except I'm going to change that slope from 4 into 0. So we could see here that if I were to multiply 0 times x, it really doesn't matter what x is. X can change, but it doesn't make a difference what it is because it's about to be multiplied by that 0. This is going to completely disappear. This whole term gets canceled out, and we actually don't write that at all. We would just write y equals 3. So when you see an equation without an x term like this, it really is implying that the slope is 0. This y-intercept part of the equation is still 3. That part didn't really change, but the slope was 0, which really just wiped out that entire term. That's really why the y is the only variable left in that equation. We don't have that x anymore because that x term is completely canceled out by multiplying by 0. Slope that's undefined is a little bit tougher to show in an equation. But thinking about what the graph looks like, let's say that's where x equals 2, and I have a point there, and a point there. So this is 2, 0. This is 2, 3. That has an undefined slope. And you can see that all the points on that line would have a constant x value. This would be, let's say, 2, -4. The x value never really changes. So an easy way to describe an equation like that is just naming the x value. This y value doesn't really have anything to do with this description. The description of this line is really just describing all of these x values of 2. So actually that is the equation that would represent an undefined line. There is no slope at all, literally, because we can't define it. So it's not like this where we could write it as 0 and then we just follow some order of operations and it goes away. We can't write that slope into this equation, so we just write it as a definition of what x values we have at each of these points. Here that would be x equals 2.